All right, hi folks, this is Larry Mussolino. I wanted to record a short video to help with fractions. And so this is always a challenging topic, and I think part of it is there's several different rules to keep in mind when working with fractions, and you have to keep track of what rule applies for the given problem you're working on. So a little bit of background. When you're working with a fraction, the top number is called the numerator. The bottom number is called the denominator. You can remember that because denominator starts with D. Think of D as down. So the number down on the bottom is the denominator. One other thing to keep in mind is when you see that fraction bar, the fraction bar really is a division symbol. So 3 over 4, when you think about this fraction bar, it's really division. So you could think about this as 3 divided by 4 if you wanted to. And that's one way to change a fraction into a decimal. 3 divided by 4 on my calculator is 0.75. So that tells me the fraction 3 over 4 is exactly equivalent to the decimal 0.75. All right, let's do a few of the typical operations you want to do with fractions. Let's talk about simplifying a fraction. Simplifying a fraction really means rewriting the fraction as a different fraction, but it's still equivalent to the starting fraction. Here's an example. How about 54 over 12? Well, I want to simplify this fraction. Sometimes it's called reducing to lowest terms. That means the same thing. Now, if I was going to work this out on a calculator, 54 divided by 12 turns out to be 4.5 in decimal. All right, here's how you simplify a fraction. It says, look for some number that will evenly divide into both the top and bottom numbers. So I'm looking for some number that might evenly divide into both 54 and 12. And when I do this, I'm looking for the largest such number I can come up with. Now I'm noticing 54 and 12 are both even numbers. So I know 2 would evenly divide top and bottom. But I'm also trying to see if there's a larger number. And I think I could use 6 because 6 evenly divides into 54 and 6 also evenly divides into 12. So that's it. I'm going to divide the top and the bottom by 6. So let me divide the top by 6 and divide the bottom by 6. Well, 54 divided by 6 on top is 9. 12 divided by 6 on the bottom is a 2. So I'm ending up with the simplified version, 9 over 2. And if you work out 9 divided by 2 on your calculator, you get the same answer, 4.5. So these two fractions really are equivalent. It's just that we wrote 9 over 2 in the simplified version. Okay, so that's it. Look for some number that will evenly divide into both the top and the bottom numbers of the fraction. All right, let's go to multiplying. Well, here's the rule for multiplying fractions. When you want to multiply fractions, multiply straight across on the top and straight across on the bottom. So let's do an example of that. Let me erase this here for a second. And let's do an example of multiplying. Multiplying is kind of the easiest operation for fractions because all you have to do is just multiply straight across. So let me do a quick example here. How about 3 over 5 multiplying 10 over 7? Well, again, the rule is just multiply the numbers straight across top and bottom. So let me multiply 3 times 10 on top. That's 30. Let me multiply 5 times 7 on the bottom. That's 35. All right, but remember, you usually want to try to simplify fractions. So let me look for some number that would evenly divide into both the top and the bottom. Well, I'm noticing the number 5 would evenly divide into both the top and the bottom. So I think what I'm going to do then is divide the top by 5 and divide the bottom by 5 to simplify. 30 divided by 5 is 6. 35 divided by 5 is 7. So 6 over 7 is the answer. All right. Let me move on to adding and subtracting. This is where students have the most trouble. All right, now, here's a very important item to keep in mind for adding or subtracting fractions. You must have the same denominator before you can add or subtract. Here's a common mistake. Let me show you a very common mistake. Don't do this, but here's a common mistake. 2 over 3 plus 7 over 12. Some students will just add straight across. So they'll take 2 plus 7 and think that's 9, and 3 plus 12, add those together, 15. This is very wrong. You cannot just add straight across. First, you have to get the same denominator. So let's do an example with getting the same denominator. All right, so let me make up a different example here. Let me erase the screen here. And let's do an example for adding fractions. How about something like, let me make something up here. How about 2 over 3 plus 5 over 4, let's say. All right, I want to add these fractions together. First, let me do an example before this. I'm sorry. Let me just do a quick example here. How about 9 over 8 plus 2 over 8? All right, well, the rule is before you can add fractions, you must have the same denominator. Well, in my example here, I do have the same denominator. It's 8 on this side, 8 on this side. Remember, denominator means the number on the bottom. The rule is when you have the same denominator, so to add fractions, what you do is you keep the denominator as is. Don't change the denominator. Don't add the denominator. So you just leave the denominator as is. But you do add the numbers on top. So add the numerators together. So let's do it in this example. I keep 8 as is, because that's the common denominator. And I'm going to add the numbers on top. 9 plus 2 is 11. That's my answer. All right, let me come down to this bottom example, though. I have 2 over 3 plus 5 over 4. These are not the same denominators. So I cannot add them yet. I got to first get the same denominator. So what you do is you look for something called look for the least common denominator. It's called LCD, sometimes we say. The least common denominator is some number. What I'm looking for here in this box is some number. I'm looking for a number such that both 3 and 4 evenly divide into this number. Well, I'm going to use 12 because both 3 and 4 evenly divide into 12. So that's a common denominator, the least common denominator. Now, I could use the number 24 because 3 and 4 also evenly divide into 24. But remember, it's the least common denominator. That means the smallest number I can come up with. Here's what I'm going to do. I'm going to be changing these fractions to have this denominator I want of 12. All right, so how am I going to do this? Well, what you're allowed to do is for any fraction, what you could do is multiply the fraction times some number over itself, as long as these red boxes are the same number. So as long as I keep these red boxes to be the same number, I could put any number I want in these red boxes. Well, let me look at the bottom. Remember, I'm multiplying these fractions, so that means multiply straight across top and bottom. On the bottom, I want 3 to multiply this red box, but I want to get the answer 12 out of that. Well, that would mean 3 times 4, because 3 times 4 is 12. But if I put a 4 in that bottom red box, I'm forced to put the exact same number in the top red box. Remember, these red boxes always have to have the same number in them. Well, now let me multiply across on top. 2 times 4, that's 8. All right, I'm going to do the same setup with this other fraction, 5 over 4. So I'm going to ask myself, let me set this up here. I'm going to multiply this guy by a number over itself. And remember, these two blue boxes have to be the same number. Let me go to the bottom. I need 4 to multiply this bottom blue box and come up with the answer 12. Well, that means I got to put a 3 in this bottom blue box. But if I put a 3 in the bottom blue box, I'm forced to put a 3 in the top blue box. Remember, these blue boxes always have to have the same number, top and bottom like this. Let me multiply straight across on top. Well, 5 times 3, that's a 15. Well, now I do have the same denominators. So I'm going to go ahead and add them. Well, here's how you add fractions that have the same denominator. Keep the denominator as is. So I'm going to leave that as 12. Add the numbers on top together, 8 and 15, that's 23. So here's my answer, 23 over 12. Okay, so very important that if you're adding fractions that don't have the same denominator, you cannot add them. First, you've got to get the same denominators on the bottom. Then you can add the fractions. To get the same denominators, look for what's called the least common denominator. That's a number that both the denominators that you have evenly divide into. All right, let me give you one other example, which involving fractions, which is to solve an equation with fractions. So this is a common item you'll come across. So let's solve an equation with fractions. All right, let me make up a quick example. How about x over 3 subtract 2 equals x over 5. All right, so I want to solve this equation. That means get x by itself on one side. That's what I'm trying to do on one side of the equation. But because this has messy fractions in it, I want to get rid of fractions as the first step. So the first step here is eliminate the fractions, get rid of the fractions. All right, well, how do you do that? What you do is first look for the common denominator, that LCD. Let's do that. I'm going to look at these denominators. I'm noticing a 3 and a 5 as the denominators I have. So I'm looking for some number. Look for some number here such that both 3 and 5 evenly divide into this number. Well, I think I use 15. Right? Both 3 and 5 evenly divided to 15. All right, here's the last step. I'll call it step 3. Step 3 is you multiply both sides of the equation by that LCD. In our case, it's 15. So I'm going to multiply both sides by 15. Now, one thing I got to be careful about is when I do this, I've got to be careful to multiply everything by 15, each expression. So I'm going to multiply this by 15. I'm going to, this x over 3 gets multiplied by 15. Here I have a 2. I'm going to multiply that by 15. On the right-hand side, I'm multiplying by 15. All right, so now let me simplify each fraction. Well, let me come here to the left. I have a 15 on top and a 3 on the bottom. Remember, this fraction bar really means division. So this is really 15 divided by 3. But 15 divided by 3 is 5. So I'm going to write a 5 there. I'm going to bring the x down with me. All right, let me come here. I'm multiplying 15 times 2. Well, that's 30. Let me come over to the right side of the equation. I have a 15 on top and a 5 on the bottom. Well, this is really 15 divided by 5. Remember, the fraction bar means division. 15 divided by 5 is 3, so that's a 3x. Here's the good news. I just got rid of fractions. Now, this is a much easier equation for me to solve. All right, well, I know I want to get x by itself on one side of the equation. How about if we move x over to the right-hand side? I don't have to move x to the right-hand side. I could move x over to the left-hand side of the equation if I wanted to, but I think it's a little easier to move x over to the right-hand side. So let me subtract this 5x from both sides. The reason I'm doing that is on the left side, 5x subtract 5x cancels out. All right, that leaves me negative 30 on the left side. On the right side, I have 3x subtract 5x. Well, that's a negative 2x. All right, one more step. Remember, our goal is to get x by itself. Right now, x is being multiplied by negative 2. If I want to get x by itself, I've got to cancel out that multiplication by negative 2. How do you cancel out a multiplication? Well, use the opposite of multiplying, which is dividing. So what that means is I'm going to be dividing both sides of this equation by negative 2. So I'm going to divide this side by negative 2, divide this side by negative 2. On the right side, I have multiplying by negative 2, dividing by negative 2. Well, those cancel out because they're opposites. So that leaves me just x. On the left side, I have a negative 30 divided by a negative 2. A negative divided by a negative is a positive, so this is positive 50. Well, that's my answer because I now have x by itself, so my answer here is x. I could check my answer on this. Let's say I wanted to check my answer. You know, maybe this is an exam problem, and I want to double check my answer before I submit it. Well, here's what I could do. Let me go back to the original equation, which was x over 3 minus 2 equals x over 5. Let me plug in. I'm going to replace x with my answer, 15, and see if I get a true equation out of this. All right, let me do it. So this is going to be 15 over 3. Let me erase some of this over here. I don't have to do this check, but it's a good idea to double check. All right, so I have 15 over 3 minus 2. I want to check if this is equal to 15 over 5. 15 over 3, that's 5. And on the right side, 15 over 5, that's 3. So we have 5 subtract 2 equals 3. Is that true? Yeah, of course, 3 equals 3. That confirms or double checks that my answer really is correct. Okay, folks, hope this is helpful as you are working in ALEKS, and please try to practice some of these examples with fractions. Fractions are very important in our course. We're going to be using them, throughout the course. Okay. All right, folks, let me know if there's any questions. Thanks.